And we are back. Welcome. Sorry I couldn't make it again. Going to try my hardest to keep these notes under 10 minutes. Let's go. First couple examples, I just want you guys to remember some of your Pythagorean triples. This one might be a little hard to recognize. I do believe this is a 3, 4, 5 triangle. It seems like all those values are multiplied by 4. So don't forget, we could technically look at this as a 16, and I just need the little PT in the corner. Nailed it. This example is a Pythagorean triple right off the bat. And this next example, unfortunately, we don't have a Pythagorean triple with a 5 and a 9. You would have to do old school 5 squared plus 9 squared equals c squared. Solve that problem. I do believe you should get a c value that is the square root of 106 for that. This whole entire process that we've been doing is called the Pythagorean theorem. And this theorem states that, I'm going to abbreviate this a little bit, if you have a right triangle, then we do know that a squared plus b squared equals c squared. So we've been working with this for some time now, where they're giving us a right triangle. This set of notes is all about the opposite, where they kind of give us a random triangle, and it is our job to determine whether or not we believe it is a right triangle, and we can actually prove this using the Pythagorean theorem. And in this case, I'm going to skip down all these. Again, most of this stuff is not too necessary, some fluff, but let's look at these examples. I'm going to highlight number 1, number 2, and number 4, and I'm going to do these with you guys really quick. The first thing I'm going to do is I'm going to label these triangles as what it looks like. If we looked at these triangles to label them based on their angle measurements, we have a choice of acute angles, obtuse angles, or right angles for these triangles. And in this example here, if we calculated this, I think we'd take 180, we would subtract 19, we would subtract 24, and you would find that this missing angle here was 137 degrees. Because it has one angle that is larger than 90 degrees, that is not how you spell obtuse, but this is an obtuse triangle. For example, number 2, we again could do the same exact process. Take your 180, subtract the 87 and the 38 that we have. You should end up with a final measurement down here of 55 degrees. All of these angles do seem less than 90 degrees, so we can consider this to be an acute triangle. And last but not least, 180 degrees, subtracting the 2 angles that we currently have, you would find that this is indeed a 90-degree angle here. And again, we could consider this a right triangle. So based on these pieces of information, we'll notice something about the side lengths in general. And with that, I just wanted to calculate a good old-fashioned quote-unquote a squared plus b squared equals c squared. Now granted, not all of these triangles are right triangles, so this shouldn't work in the first 2 examples that we have. But let's just see. Again, the only rule with a squared plus b squared equals c squared is that c squared must be the largest value that we have for the sides, which I believe should be the 17. So let's calculate this really quickly. If I have an 8 squared plus 10 squared, and I just kind of calculate the c squared on its own really quickly, because I know they're not going to be equal since this is not a 90-degree triangle, I should end up with 64 plus 100 for this side to get a 164. And then 17 squared we just know as 287. And when you look at these values, they are not equal. And in fact, realistically, the values that we see on the left, the a squared plus the b squared, strictly seem to be less than all the numbers that we see for the c squared variable. Let's take a look at number 2 really quick. Here, if we do the same exact process with our different numbers, we choose the largest side to be that c value. We would end up again with a 7 squared plus a 10 squared. And again, this is not a right triangle. I do not believe that this should be equal. So instead, we will calculate the c squared separately. 49 plus 100. We should get 149 on that left side. And then 12 squared we know as 144. And this scenario, we notice that these values of a squared plus b squared seem to be greater than the c squared value that is isolated. And this trend will continue throughout. And this is the main feature of today's notes, is recognizing when you are given a triangle, we can perform this a squared plus b squared calculation. We can perform the c squared calculation, and depending on how they relate, whether they are a squared, b squared is less than your c squared, or if your a squared plus b squared is bigger than your c squared, we can actually determine whether these are obtuse or acute triangles. For number 4, this one we would probably figure out, and this is actually a Pythagorean triple, so we do know that this one works as well. 8 squared plus 15 squared, and if we just happen to calculate 17 squared isolated by itself, we should end up with 225 and 64. Grand total of 289, which just so happens to be the value of these. And again, that would make sense because we do know that we have ourselves a right triangle, so we know a squared plus b squared should indeed equal c squared. Take a look at examples 3, 5, and 6 if you want a couple other ideas or examples of those, but you would find similar processes here. I'm going to skip this section of the notes. Really, I just wanted to put in a couple informations about triangle number 4 here. There was also a second triangle that should have happened. I will let you guys determine which triangle that was here in your notes though. But the big reasoning that we wanted to come down is this right here. And I think these next couple boxes that I'm going to highlight are the major takeaways from this lesson. Those major takeaways, again, if we recognize that a squared plus b squared is exactly equal to c squared, we have ourselves a right triangle. It is proven. On the other hand, we had some acute triangles. The one that we talked about in specific was triangle number 2. And again, we ran through here, we found out all these values, and the big, heavy takeaway was this piece of information here that states if I end up with some values where a squared plus b squared is greater than the c squared value, then we knew that this was actually an acute triangle. And the final piece of information that we really learned from this one was our obtuse triangles, which again, we had calculated those. We had the first triangle, triangle number 1, which leads us to the third major piece of information from today's notes, that if my a squared value and my b squared value added together are less than the c squared value, we know we have ourselves an obtuse triangle. This is why we call it the converse. If we don't know a triangle is a right triangle, we can actually use the quote-unquote Pythagorean theorem to either prove it is a right triangle or compare the a squared plus b squared values to the c squared value to determine whether it is an acute triangle or an obtuse triangle as well. The last thing that we have to note from this particular section is a cool fact about the triangles, that the sum of any two sides of a triangle must strictly be greater than the third side. I can give you a very brief example of this. Let's say I have a side length right here that is the size of 10, and I have two other sides, one here and one here. And let's say I just have these as a value of 5 and 3. Although I have drawn this triangle, it looks like it is enclosed. This triangle is actually a non-realistic triangle. The reasoning for that is that these two sides right here, if you add those together, they actually do not equal a value that is larger than that third side. Thus, this triangle, although I drew it connected, realistically will probably look something like this. You'd have one side that's 10, you'd have a side that's 5, and a side that's 3 right here, and we'd be missing a huge gap here that would not allow this triangle to physically connect itself together. So there are certain values where we look at them and say, these don't really work for a triangle. And there's a nice rule for it that I just mentioned to you guys, that when you add up two of the sides, they do need to be strictly larger than that third side. So we go about this by taking our values and locating the largest value. From there, all we have to do is make sure, if I take the two smaller numbers, will those be larger than the third side? 6 plus 7, I believe that is a grand total of 13. Is 13 larger than the side it is of 10? Yes, it is. So we check that off. I could go about this now and take away this whole entire process of this notes that we have and say, could you tell me if this is now a right triangle, an obtuse triangle, or an acute triangle? Well, that would mean we'd have to take our a squared values and b squared values, compare them to the c squared values. 6 squared is 36, 7 squared is 49. Add those together, I get 85. My c squared value should be 100. So I ended up a situation here where 85 seems to be less than the number 100. According to the notes we had earlier, that would categorize this as an obtuse triangle. Letter B, we're going to do the same exact thing here. Take your larger side that you have. Let's first make sure that this can indeed be a triangle. The two smaller sides, if I add those together, I'm hoping that those numbers become larger than the biggest side that I have. And what do you know? 49 is indeed larger than 41. So we do have ourselves a valid triangle. What about, is this a right triangle, obtuse triangle, or an acute triangle? I'm really hoping you recognize these values right here. This is, in fact, a Pythagorean triple, the 9, 40, 41 triangle. So I do think we can immediately categorize this as a right triangle. And again, remember, anytime we use the Pythagorean triples, I would like to see the little PT just to verify that you do not need to show any work, but yet can receive full credit for this. Letter C. Let's find that largest side. Let's see if my two smaller sides add up to be bigger than that. I have an 8 plus a 12. If I look at this, at first you might think this could work. But unfortunately, remember, you have to be strictly greater than. 20 is not larger than 20. It's only equal to it. So this one does not work because it is not greater than those values. So this is actually not a triangle at all. That's the scenario that we kind of saw right up here, where we might think it's a triangle just because we have three sides, but one side or two sides are just a little too short to actually connect together. And last but not least, let's check out this last one. First of all, do we end up with a number that is, if I add the two smaller sides, do I get a value that is larger than the third side? If I add 3 and I add the value of 4 square root 5, and I compare that to the number 9, this might not seem like the largest value that you have, but realistically, if you used a calculator, which I'm going to do really quickly, if you have 3 plus 4 square roots of 5, you actually end, I multiplied those. you do actually end up with 11.944 something, something, something. Compare that to the number 9. Yes, this does pass our triangle test. Now, what kind of triangle is it? Let's calculate the a squared plus the b squared. A squared plus b squared on its own. Let's compare that to the c squared values. Three squared should just give me 9. Remember this, if I was going to rewrite this, this is technically the value of 4 root 5 times 4 root 5. So we do those insides times the insides and outsides times the outsides. So I end up with 16. And then I'm going to actually utilize that trick we learned earlier yesterday or today, that when we multiply two of the same square roots together, you just get what is on the inside there. We should end up with just 16 times 5. This means we have 9 plus 80. We get a grand total of 89. Is that, or what does that value compared to the 81 we get from the 9 squared? I believe 89 is larger than 81. From our notes that we took earlier, that means we have ourselves an acute triangle. Those are the major takeaways, everything that I kind of have highlighted. So every round box, I guess I didn't technically highlight this one, but let's give it a highlighted border just to make it special. With that, you guys should be able to do pretty well on the homework. 4 major takeaways from you guys. I tried to keep the notes under 10 minutes. I'll see you guys on Wednesday. Good luck.